Hey guys, BuildZoid here, and today we're going to be taking a look at yet another DDR5 memory overclock, this time on the MSI Z690 Unify X. I'm again using the engineering sample Corsair Vengeance DDR5 kit, the 6200 CL36 kit. This is the weaker of the two kits that I got sent for the DDR5 Invitational competition, so that's why I'm using it for these kinds of videos, because I'm like, I'm keeping the good kit for the scores, and this one is just kind of like, well, I'm not using this one for the competition, so content here. That's what we're doing with these. Anyway, these are SK Hynix MDI 16 gigabit based memory sticks. They're single rank. They use a 10-layer PCB. The 10-layer PCB, well, the ICs are supposed to be binned, but again, like, these are the weaker of the two, like, these are the weaker sticks from what I've gotten, so I don't really think, like, to me, these really don't seem amazingly good, like, even compared to the Gigabyte kit that I have, so that's kind of why I've been using them for the memory overclocking videos that I've been making, with, like, the Corsair sticks that I have. And the... Yeah, and so basically, so in terms of memory chips, I don't think they're too far from, like, retail quality. The biggest difference is that they use a 10-layer PCB. I am not sure that 10-layer what kind, it's too early for me to tell if that 10-layer PCB actually achieves anything that the 8-layer PCB didn't. Let's just put it that way. It certainly doesn't seem to hurt anything, so yeah. Anyway, and then, of course, I'm using the MSI Z690 Unify X. I have a fan on the memory sticks. In this case, the thing with the fan on the memory sticks is, like, if you're running high memory voltages, you definitely want a fan. But even at low memory voltages, just making sure that the memory sticks run cooler will give you more overclocking headroom. So, yeah, because the thing is, I'm really not pushing the sticks super hard in this configuration right here. And I still have a fan on them because, well, if you're serious about memory overclocking, you should probably just have a fan, like, pointed right at your memory sticks, in my opinion. It helps a lot. It solves a lot of potential, like, issues with getting errors really far into various stress tests, because your memory sticks don't just keep getting hotter and hotter like they would normally do. Especially because memory, like, the thing with memory cooling is it doesn't produce a lot of heat, but it is temperature sensitive, so it takes forever for a memory stick to get to a temperature at which it's unstable. And it really doesn't take much to keep memory sticks just ice cold. So, yeah. Anyway, so motherboard memory, the CPU is the 12900K again, because I was doing the oscilloscope testing with the 12900K. The 12600K isn't really useful for that because it doesn't have as many cores. And so, yeah, since the 12900K was already in the board, that's why I use the 12900K for the memory overclocking here. Anyway, let's take a look at the results. So I have gone ahead and checked that this overclock is retrain stable, because I've already tried to set up a 6800 megabits per second memory overclock on this board before with this 12900K, and that did not go well. Admittedly, I was trying to do, I think, CL32 with, like, TRCD39. So yeah, but the main issue with that overclock was, like, I got a 400% mem test pass, and then I restarted the system, and then it failed mem test in 16 in, like, first 10-20%. So yeah, that wasn't great. Whereas this overclock, I've restarted the system 5 times. Every single time, it passes both Linpack and memtest to, like, I didn't, like, this final restart, I ran it out to 500%. Well, the first test was 500%. Then the, like, test 2, 3, 4, those were all to, like, 200% with just, like, 20 loops of Linpack, not the usual, like, 30 plus that I do for the sort of, like, full stability. And then this fifth one, we have 40 loops of Linpack, 500% memtest, and it's stable. So combined, I think this memory's technically been, like, between the various restarts, I think the memory's been tested to, like, over well over 1,000%. Because just, like, test 1 and test 2 were both over 500%. So yeah, that's 1,000% right there. And then, so probably, like, 1,600, yeah, like 1,600% memtest over multiple restarts. And over 100 loops of Linpack over multiple restarts, and it's nice and stable. It never errored out on any of them, so it is retrain stable, it is restart stable. And like I did cold starts, like I'd turn off the system, turn off the power supply, and then wait a while, and then turn the power supply on because, yeah, because that's been an issue with Intel CPUs ever since they introduced Gear 2. Is in Gear 2, for whatever reason, if you're pushing the memory controller really hard, at some point it starts just randomly failing. Like, you'll get into Windows. It's not like it'll fail to post. You'll get into Windows and it'll be horribly unstable for no apparent reason. So that's kind of the reason why I had this like crazy procedure of like making sure that it like survives reboots. Because that is a problem I've run into with this setup. I've also run into it with the Tachyon and yeah, it's and actually every single Z690 board. Like as soon as you start pushing them past 6200 in my experience, like the 4-dim boards do it at around 6400, it starts becoming an issue. The 2-dimmers start having issues with it past 6600. So yeah, I like the Gear 2 sucks. Anyway, yeah, so it is very stable. So it passes Linpack. CPU's at 5.1 gigahertz. The ring is at 4.8. And the Linpack performance is really solid, especially considering, like, the thing with this overclock is really not that aggressive on the primary timings, right? We're just at 34, 42, 42, 28, 2T command rate. But the thing is, all of the subtimings are very tight. And, well, almost very tight. I'm not really thrilled about having a TRRD SG of 7, but it doesn't really make a difference. Like, the thing is, the TRRD same group timing on DDR5 makes a lot less of a difference than it did on DDR4 because there's a lot more bank groups to go around. So you don't, like, the probability that the next piece of data that, like, that the next activate command is going to be to the same group is lower because there's 8, like, instead of 4 groups, you now have 8 groups for the memory controller to play with. So, yeah, so basically we have a lot of very tight timings. The end result, and also the memory speed is like really, really high. And the primaries, like this is one thing that bugs me, especially on DDR5. Like changing the primaries basically doesn't do anything for like performance. And it really is like the subtimings that make big differences. And either way, so yeah, with these relatively like not that great looking primary timings, you know, we're getting 52 nanoseconds of latency in IDA, because we are on 100 megahertz BCLK, so I can actually run IDA and it's not bugging out because IDA's a terrible benchmark. So, yeah, we're getting over 100 gigabytes per second of read, write, copy. Of course we are. We're at 6,800 megabits per second. Like, yeah, you're going to have tons of bandwidth at this point. Also, here's the Intel MLC test, which gets down as low as 49.24 nanoseconds. Which I don't believe is the lowest figure I've seen, but I think, actually it's definitely not the lowest figure I've seen, but I think it's one of the lowest figures I've gotten fully stable, I think. Yeah, like that's a good result, and also the IDA result, like 52 nanoseconds is solid. When IDA isn't glitched out. Because if you glitch IDA out, it's actually, like, you can, like, if you glitch IDA out by messing with the BCLK, you can get the latency to be pretty much whatever you want. Like, I'm pretty sure there's a screenshot of a 12th gen CPU doing, like, 20 nanoseconds on DDR5, so, yeah, not a good benchmark. Which is like, Intel MLC, on the other hand, like, it never runs into that issue, which means this is a much better benchmark if you want, reliable results that don't change based on if you've fiddled with the BCLK. However, it's worth noting that this benchmark is really meant for Intel CPUs, so it doesn't work for AMD. Or it might give you really strange results on AMD CPUs. Anyway, so that's like the sort of pure synthetics. I don't really consider Linpack a truly synthetic benchmark because this is actually just trying to do a lot of math. And consequently, since it's AVX accelerated, it needs a ton of memory bandwidth. And what's actually kind of crazy with DDR5 is because DDR5, well, the thing is, it's not just that it needs a ton of bandwidth. It also, like, the nice thing about Linpack is it scales with latency, it scales with bandwidth, it scales with everything. It's almost like borderline perfect memory benchmark. There's other memory benchmarks that also scale with almost everything. SuperPi would be one of them. But SuperPi on Windows 10 is extremely inconsistent unless you go out of your way to fix the OS, and yeah, I'm not bothering with that. For the sake of just doing kind of also, it doesn't, like, if you're doing a daily, if you're overclocking your daily system, like, you're not going to use SuperPi to validate your memory settings as in terms of performance, because it's going to be horribly inconsistent. Like, you need a dedicated SuperPi operating system just so you can run that benchmark reliably. So while it's really sensitive, it's not great. Whereas Linpack is also really consistent. And the thing is, with DDR5, you have so much memory bandwidth that it actually is primarily memory latency bound, which is kind of crazy to think about, because I think this kit, which is 6,200 megabits per second by XMP, I should have a screenshot of that, so I'll pull up the screenshot just to show you the performance scaling. Screenshots, and okay, so this is the current settings, and that's 3,400, wait, what? Oh, yeah, so here you have so this is the XMP, right, which is 6,200, 36, 39, 39, and we're getting 620 gigaflops. And then if we go over to, man, why is the Windows image app so bad? And then here we have like a 6,800 megabits per second, but without any of the timings dialed in. And you can see, like, it barely made a difference, because on DDR5, you have so much memory bandwidth that suddenly Linpack, which is historically primarily for DDR4, this is primarily a bandwidth benchmark, with a pretty significant latency component, but primarily a bandwidth benchmark. Yeah, on DDR5, this basically becomes a latency benchmark with a insane amount of load on the memory controller, which is why I like using it, because you get the nice thing about Linpack is it's both a CPU stress test, memory controller stress test, and it gives you a performance number for your memory settings. So the main thing is, though, you do need to match your CPU and uncore frequency if you're going to be making comparisons against people. 632 gigaflops at 5.1 gigahertz with 4.8 ring is very strong. Like, that is a very, very strong result right there. As well as just the 631.8 average. It runs best if you run Linpack first. It's also worth noting, if you run like memtest first and then run Linpack will actually give you slightly lower results. If you have any monitoring software running while running Linpack, that'll also lower the results, because it's very memory intensive, and literally anything running will screw over anything that's like super memory sensitive. Which is also one of the reasons why the IDA latency benchmark is an inconsistent pile of trash. So, anyway, yeah, so that's the settings. I haven't yet run Y-Cruncher on this, but I can't imagine that'll have any issues. So we'll just quickly hit it with Y-Cruncher. I don't have AVX512 enabled, since Intel is going out of their way to start disabling AVX512 in hardware on their newer production CPUs, so this chip does do AVX512, but I have that turned off right now. Also, if you're stress testing with Linpack, AVX512 makes it run cooler, and you don't really want that. Because that makes it less stressful if it's running less hot. Interestingly enough, Y-Cruncher actually runs a little bit less hot than Linpack does. But it's actually harder to pass in certain scenarios. Like, I have run into settings that would run Linpack and then would need slightly more voltage in order to do Y-Cruncher. So, and that's core voltage, not memory voltage. Anyway, so that's 72.6 seconds with, everything open here, so that's just fine. So yeah, Y-Cruncher runs, of course it does. Like, after 40 loops of Linpack, I wouldn't really expect much of it. Well, like, actually, with the way the CPU is set up right now, it won't run Prime 95, but that's more down to the fact that we're on a 240mm AIO, and it just doesn't have the cooling capacity for small FFT's Prime 95, but anyway. Yeah, so in terms of the memory, like, memory and memory controller stability, it's great. Like, this is very stable. I would totally daily this. In fact, I trust this overclock way more than some of the, actually, it's not that I trust this one way more. It's more, I've put way more validation time into this one than into some of the other overclocks, because especially for DDR4, like, the crazy, like, restart, run stress test, restart, run stress test again, restart, run stress test again thing that I did with this is not necessary. Most DDR4, well, with the exception of 11th gen CPUs in Gear 2, but like on Ryzen systems, you don't need to do that. You just need to make sure that you're like Ryzen, if it has issues, it will just fail to post completely. So you don't have to worry about like getting into Windows, but with like incorrect memory, like with some kind of weird initialization issue that then shows up as a random instability. Ryzen, if it has initialization issues, will just not initialize sometimes. So you can just like reboot the system, like cold boot the system a few times, and if it does it, then it's fine. Whereas with Intel CPUs, that's not enough. So that's why this technically had like more time put into it than a lot of other memory overclocks that I've done. But yeah, so anyway, that's the settings we got here. The performance is solid. Like, I'm really happy with it. In fact, I'm actually surprised that it's hitting such high numbers in Linpack, considering how like loose the primary timings are. But the thing is, like with DDR5, the primary timings really don't matter that much. It really is more about the subtimings than it is about the primaries. So, like, they do help, because, again, Linpack is very latency sensitive, but the thing is, Linpack also is just doing a lot of memory accesses, and so, like, your CAS latency is only really used for, like, if you're accessing 1 byte of data very infrequently, then, like, your CAS latency is very important. If you're doing a lot of random accesses, then the CAS latency sort of stops being as much of a factor for performance, and that's sort of, that's closer to what Linpack is in terms of a memory benchmark. Anyway, yeah, so I'm really happy with this overclock. I mean, I wouldn't be showing it to you if I wasn't, so so making that statement is kind of pointless. Let's take a look at the actual voltage settings. And this is the other thing that I'm really happy with, is like, I didn't, like, this one isn't pushing any kind of extreme voltages or anything. Like, this one is very, like, I'd say it's a rather mild overclock. That won't work on 90% of Z690 motherboards, but mild. If you have a 1 DIMM per channel like the Unify X or a Tachyon or a Apex that isn't one of the original, that's the newer production Apexes. Anyway, so let's go over the voltage settings. So I have, for the CPU, we have mode 6 LLC, which is relatively droopy, 400 mil. This, from oscilloscope testing, mode 6 seems to basically be the best LLC to use if you're using the socket sense instead of the VCC sense. If you use VCC sense, you actually want to be on mode 7. But VCC sense, well, I'm just not using it because I've got the scope hooked up. Voltage on override mode, 1.38 volts. This is perfectly safe for long-term use on 12th gen CPUs. Not concerned about that at all. System agent is on override mode, 1.35 volt system agent. This is probably way higher than it needs to be, but it's not going to hurt the CPU, so, whatever. CPU VDDQ at 1.45 volts. This is probably actually necessary to be where it is. This is as high as I'd be willing to daily it, long term. And, yeah, so potentially something to try might be, well, no, I'd daily it like this, to be completely honest. I actually, yeah, like, I would. Like, this is as high as I would set this voltage, so I'd leave it at that. Then CPU VDD2, we're at 1.4 volts, which is very safe. But the thing with VDD2 to keep in mind is that this voltage sweet spots. So more VDD2 does not necessarily mean less problems. And in fact, the Unify X on the A22 BIOS that I'm using here, it's not at all like the Tachyon where you can just run insane VDD2. This board, it's not quite as bad as my Apex, which just freaks out if you give it more, or even the Torpedo board I think was on like 1.3 volts of VDD2. Yeah, so this board has like, it has a completely different memory topology from all of the other boards, so of course, and also I don't know what kind of, you know, memory controller configuration differences there are between the Unify X and the Apex and the Tachyon and all the other Z690 boards that I've used, but basically every motherboard and every memory kit is going to have its own VDD2 sweet spot. And for this setup right here, I'm not sure that 1.4 is the only voltage that works, but it is a voltage that works, that is safe, and I am not going to mess with it, because lowering it or raising it is liable to cause more issues than it's worth. Anyway, CPU auxiliary voltage, we're at 1.9 volts, which is perfectly fine for long-term use. And this can help with basically stabilizing higher SA and VDDQ voltages, so yeah, there's a decent chance this would still work just fine at 1.8, but also 1.9 volts of input voltage is just not going to harm the CPU any way, shape, or form, so it's just fine. Then we have the PLLs, which these also sweet spot depending on your CPU. These sweet spot depending on your CPU. So with this chip for the core, like basically CPU PLL SFR voltage makes it a bit more, like makes CPU overclocks a bit more stable. So core clock, as in you get less crashing with lower voltages. Ring PLL, and when I say less crashing, I mean like you can use less voltage without crashing in stress tests. That would be the better way to word that. Ring PLL 0.975 volts just helps with stabilizing high ring clocks a bit. SAPLL 0.96. This helps with both ring clock and memory clock. And to be fair, the ring PLL also kind of helps with that. And then MCPLL just helps with the like high memory speeds. So that's at 1.05. All of these are safe. In fact, the board really won't let you put them outside of the safe range. So yeah, I wouldn't be worried about any of those. And then for the memory, and this is my favorite part of this, we're just at 1.45 volts. Like, this is very mild, right? Like on some of the other boards, like I've pushed as high as like 1.55, 1.6 volts into the memory, at which point you really, really need a fan on DDR5 sticks, because they get, like, if you don't have a fan, they're going to get very, very hot. And that's bad for their health. Especially with how much voltage you're pushing into them. But yeah, here we're just 1.45 volts, and it runs great. Partially because the primary timings are relatively loose, but that's kind of the neat thing, is a lot of memory timings don't really need a ton of voltage. So let's take a look at the timings, right? Command rate, we're at 2N. The 1N works up to 6600 on this BIOS version. And yeah, for this setup, I decided to, and actually for Linpack specifically, it's pretty likely that actually a 6600 1T command rate setup would be faster. But yeah, I like 2N, 1N, like I wanted to go for a high memory speed with this setup. So yeah, we're on 2N, because on 1N, we're not booting 6800 megabits per second. Anyway, CAS latency at 34, TRCD at 42, TRP at 42. Good kits should be able to push like all of these a bit lower, but I'm not sure if at 1.45 volts. So yeah, and the thing is, like, what you need to consider with these timings is if you lower your TRCD from 42 to 40, that's like a 5% reduction in TRCD time. And basically that doesn't show up as much of a visible performance difference, right? Like primary timings, especially when they're this large, like trying to eke out one tick of a timing that is literally is mid, like, you know, that's like 42. Reducing this by 1 is really not going to change your performance drastically whatsoever. So that's why I'm kind of cool with just leaving it at 42, because it doesn't really matter. TRAS at 28 literally cannot go lower. The register on the CPU does not support any TRAS value less than 28. So, I mean, you can punch in less than 28, but I'm pretty sure the CPU literally just ignores that and uses 28 in that case. TRFC at 366, which is quite low. One thing to keep in mind with DDR5 is if you set your TRFC too low, you start hitting the on-die error correction really hard, and it basically starts showing up as like random regressions in performance. Yeah, so that's something to watch out for, and that is especially obvious if you have a maxed out TREFI. Same goes for the TRFC per bank. So these are not the lowest TRFC and TRFC per bank that I'm able to use. Like for benchmarking, I've used lower values. So these aren't really like these aren't even close to the point where you start seeing like weirdness with performance. Also, if you set them low enough, you'll actually just beat the on-die error correction and the memory won't run anymore. But yeah, so these are the values I basically use for all SK Hynix kits so far. These won't work for like Micron, and they won't work for Samsung as far as I know. TREFI is at 65,000. Technically, you could set this a lot higher, but again, you start risking running into the error correction. Also, keeping your memory sticks cooler makes them better at retaining data, just by the way, which is what these timings deal with, the refresh interval, refresh per bank, and refresh cycle. These are all just timings to, because memory basically loses whatever data, like all, man, do I really need to explain this? I feel like I don't want to explain it. Anyway, they're refresh timings. If you set any of these too aggressively, you start hammering the on-die error correction. Then we have a few timings that are set to auto because there's no point setting them. Literally, like there's other timings further down in the BIOS that control these because the CPU literally doesn't have a TWR register. So that's why that's on auto. Anyway, then we get the TRRD and TRRDL, which are at 4.7. Ideal would be 4.4, but the difference between 4.7 and 4.4 in terms of performance on DDR5 is minimal because you got 8 bank groups, not 4. So TRRDL, which is the same group, activate timing, is pretty unlikely that you're going to be using that one the memory controller is going to be using that timing a lot. And so consequently, you know, and in a lot of scenarios, you might find that TRRDL needs to be surprisingly loose compared to TRRD. And so this works out fine. Like you still get basically almost the same performance as 4.4, but not the instability that 4.4 can sometimes use. Another option would be like 4.6, 4.5, but you know, the performance benefits of going from 4.7 to 4.6. Like it's hard to notice the difference between 4.4 and 4.7. So 4.7 versus 4.6 is basically the same thing. Anyway, RTP is another timing that there's like other timings further down in the BIOS that control this one, so that's why that's on auto. TFAW is at 16 because it literally cannot be any lower than that. TCWL is at 32. It could be lower, but that'll depend on how much memory voltage you're running and your memory sticks, and with this setup as it is right now, 32 works. So yeah, if you had like stronger kit or if you were running more memory voltage, you might be able to push that one lower, but it also, like going from 32 to 30 or even 28 on your TCWL is not going to bring you some life-changing performance differences. So yeah, apparently I forgot to set TCKE to 4. Oh well. Yeah, so this one, apparently I forgot to do that. The lowest you can set that one is 4. And yeah, I don't know why it's not set to 4 on literally every... Yeah, I guess somehow that one just escaped me. Like, oh well, so that one's on auto now. I guess it would be worth trying these settings with TCK set to 4. If you don't feel like being adventurous, then you could just not do that. And leave that one on auto. Then TCCD and TCCDL, we have 7 and 11. Neither of these goes any lower because it'll be unstable if you try to set them any lower. Then we get to the turnaround timing controls, and here we have 11.7 for the read-to-read same group and read-to-read different group. These do not go any lower than this. Then we have write-to-write same group and write-to-write different group. 9.7 doesn't go any lower than that. Also, all of these timings that are on auto do not apply to our current memory configuration. We have single rank DIMMs, 1 in each channel, and these timings, like DR stands for different rank. Well, there's no different rank, right? Like we have 1 rank on each channel, therefore there is no different rank because these timings are for each channel. If you had a dual rank memory stick or 2 memory sticks on the same channel, then the different, actually, no, if you have 2 different sticks, then it would actually be different DIMM. So, which of course is like this timing is literally never used on this motherboard because it physically doesn't have those extra DIMM slots. So that one should, like, honestly, if MSI decided to remove it from the BIOS, that would be completely fine. They won't do that because that would require this board to have like a completely different BIOS layout from all their other boards. But like, they could do that and it wouldn't make a difference because that timing is literally never used by the CPU's memory controller on this motherboard. Anyway, different rank timing only applies to dual rank DIMMs. We don't have dual rank DIMMs in here, so that doesn't matter. Then down here we have the read to write, same group and different group. These are both at 19. With more voltage, these can go lower, and well, at 1.45 volts, we're stuck at 19 with this memory kit. Yeah, they can go as low as 17 if you have enough voltage, but with the but it also doesn't really like it'll make a difference in benchmarks. It won't really change your life though. So that's kind of that. Like for daily, I'm happy to leave them at 19. On auto, they would be at like 20 or 22. Actually, no, they'd be at 20. So, you know, slightly better than auto, but because I'm not running more voltage into the DIMMs, this is where they bottom out. Then we have the write to read timings, which are at 58 and 48. These, they might go a little bit lower, but like not much lower. So that's why those are where they are. And then we get to the sort of more fun timings. TWR pre is at 48. I've tried lower values. It doesn't work, to my great surprise. So for whatever reason, this board, because it might be tied to the voltage I'm using. I've not really spent a lot of time at at speeds this high with voltages this low. I've not done that much. So, yeah, but anyway, so TWR pre at 48. Less than this doesn't work with this setup. If you add stronger sticks, it might work. If you give them more voltage, it should work. Anyway, TRD pre, we're at 12, which this sets the RTP timing, you know. So that's at 12. So effectively, we have an RTP of 12 right now. PPD's on auto because it turns out there's a power down disable option down here, so you can just disable that instead. And, oh, we're down. TXP's at 4. This helps your memory latency a bit. And then TWR PDEN is at 48. And the combination of TWR pre and TWR PDEN sets the TWR timing. So that's why if you go back in the video and look at the TWR timing that I have in MemTweakit, it's at 11. And that's because TWR pre and TWR PDEN are both at 48, while the TWR timing is set to auto. So, yeah. And I think that's everything in terms of timings. Yeah. That is actually everything in terms of timings. So, that's it. That's a very stable 6800, 6800 megabits per second CL34 with not that much voltage. Now, there is a chance, like, again, these are engineering sample sticks from Corsair, so maybe they are significantly above average. The thing is, when I was testing them with very high voltages for benchmarking, I wasn't having much success with these, which is why they got relegated to doing YouTube videos like this one. So, yeah. They might be above average at low voltages. I don't know. I don't have that many memory kits yet. Yeah, that's it. Right, and then, yeah, like ring 48, AVX ratio set to 0, and like no AVX offset, and then 5.1 on the CP cores. Oh, and then if you want to disable the E-cores on your MSI motherboard, you have to go over here and do this option, which, yeah, alternatively, you could do, like, yeah, like, that's the reason, like, alternatively, because the thing is, this setting down here doesn't let you go below 1, which is kind of dumb. So, yeah, I'm not really sure why we have both of these available, though. Like, why this is here, and this is still here, because, yeah. Anyway, that's it for the overclock. Well, yeah, that's it for this video. So, I'm pretty happy with the settings. or, well, pretty happy. I'm very happy with the settings. This is the first time I've actually gotten 6800 megabits per second fully stable with this CPU. I have a sneaking suspicion it's because I'm using looser timings than what I was, like, looser primary timings than what I've been, like, insisting on in past attempts. Because, like I said, like, earlier with this board, I tried, like, 6800 CL32, and yeah, that wasn't really going anywhere. It was, like, I just couldn't get it to stop erroring out randomly, so... yeah, anyway... I guess I should just, like, I'm just going to pull up memtweak it again, so yeah, you can see my TWR timing down here is 11, even though in the BIOS it's set on auto, and RTP is also 12, even though in the BIOS it's set to auto, and the BIOS is actually reading out RTP as being 24, which is like, nah, the BIOS timing readout just isn't doing its job properly. So, yeah, anyway, that's it for the video. So big thank you to MSI for the board, thank you to Corsair for the memory kit, and thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comments section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There is a link to that down in the description below. There's also the AHOC Teespring store where you can pick up shirts, stickers, posters, you know, the usual YouTuber merch. Then there's also the, Teespring. And then I also, as of recently, have a Bandcamp for my solo, like, industrial metal project. So if you'd like to check that out, there's a link to that. And yeah, any of them is a great way to support the channel. So if you check them out, that would be much appreciated. And that's it for the video. So thank you for watching, and goodbye.